Hi there, and welcome to this lesson on Pure Mathematics 4. In this lesson, we're on Chapter 3, 3.2, and Trigonometric Parametric Equations. And what we'll be looking at first of all is how you convert trigonometric parametric equations into Cartesian form. And usually the easiest way to do that is by using the appropriate trigonometric identity. Okay, we'll go straight into an example. Let's say you had the curve with parametric equations x equals sine t plus 1 and y equals cos t minus 2 for any value of t. By using the identity sine squared t plus cos squared t equals 1, show that the curve can be written in Cartesian form as follows, and hence sketch the curve. So what we'll do is we'll go to the parametric equation for x and rewrite that, getting sine t in terms of x. Then we'll do the same for the parametric equation with y, getting cos t in terms of y. Once we know what sine t and cos t are equal to, we can substitute them into the identity sine squared t plus cos squared t equals 1. I'll let you have a go at making sense of all of that. So pause the video, have a go at this, and then come back to me when you're ready. Okay, let's have a look. So as I said, we'll begin with the parametric equation for x, but rewrite that so that we've got sine t in terms of x, which will be sine t equals x minus 1. Then we do the same for the parametric equation in y, and rewrite that to get cos t in terms of y, which gives us cos t equals y plus 2. And all we have to do then is substitute sine t and cos t into the trig identity, which we know is true for all values of t. So substituting those values in gives us x minus 1 squared plus y plus 2 squared is equal to 1, which is what we were hoping to get. And then part 2 asks us to sketch the curve. Well, x minus 1 squared plus y plus 2 squared equals 1 is a circle with center 1 minus 2 and radius 1. So it's a circle, center 1 minus 2 and radius 1. It'll look like that, just touching the y-axis there at minus 2. Okay, example 2. This time using the identity cos 2t equals 2 cos squared t minus 1. Show that x equals cos t minus 5, y equals cos 2t. And this time the domain is restricted, and this will matter a lot for this question. The domain is restricted from minus pi by 2 radians up to plus pi by 2 radians. Don't worry about that initially. First of all, show that this can be written in Cartesian form as y equals 2x squared plus 20x plus 49. And for that part of the question, we do exactly the same thing as we did in example 1. But then it goes on. It says for this function, they haven't said the domain. They've said x will be between a and b, and you have to find a and b. So you've got to find the domain of this function. And then for part 2, you also have to find the range of the function. Now, hopefully you'll remember that we learned the method for doing that in the last lesson. So you need to just refresh yourself on that. Anyway, I'll let you have a go at working your way through the whole of this question yourself. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. So we begin by saying the first parametric equation is just x equals cos t minus 5, and we rearrange that to get cos t in terms of x. The second parametric equation is y equals cos 2t. It's never helpful to have different angles, so this we rewrite using the identity for cos 2t, which means that y equals 2 cos squared t minus 1. Well, we know what cos t is because we've got it from the other parametric equation. Cos t equals x plus 5. So we can substitute that in there, and that will give us y equals 2 into x plus 5 squared, take away 2. Then all we've got to do is multiply out the brackets and collect up terms. And if we do that, eventually we get to where we were hoping to get to. Y equals 2x squared plus 20x plus 49 is the Cartesian form of this parametric equation. Now, the question then goes on and says, find the domain of that function. Find the values of a and b. What do we have to do to find the domain of this function? We need to go back to what we learnt in the last lesson. So x between a and b is the domain of the Cartesian form of the equation. Going back to the parametric form, if x is some function of t, g of t, and y is a function of t, h of t, where the Cartesian equation is y equals f of x, then the domain of f of x, which is what we want to find, that will be the same as the range of g of t. Now what's g of t? That's the parametric equation for x. So g of t is cos t minus 5, where we're told in the question, t has to be between minus pi by 2 and plus pi by 2. Now what I'm going to do is sketch cos t. So cos t between minus pi by 2 and plus pi by 2 radians is that part of the curve. So that's what g of t looks like. Now what I need to find is the range of g of t. Well, between that range, minus pi by 2 and plus pi by 2, the maximum value of cos t, so I'm really looking at the maximum y value. The maximum value of cos t will be up here at plus 1, and the minimum value of cos t, it's like the lowest y value, and that'll be down here and here at 0. Now that's the range. The range is saying what values can the function take. If you had y, it would be what values can y take. And it can go from 0 up to 1. So that's what we've just done. So between minus pi by 2 and plus pi by 2, the maximum value of cos t is 1. The minimum value of cos t is 0. That means that for minus pi by 2 up to pi by 2, the maximum value of cos t minus 5, which is what we actually wanted to find. X is cos t minus 5. We'll put in the maximum value of cos t, which is 1, take away 5, and that gives us minus 4. And then similarly, the minimum value of cos t minus 5, which is what we're interested in, that'll be the minimum value of cos t, which is 0, take away 5, which is minus 5. Therefore, the range of g of t, and g of t is this parametric equation in x equals cos t minus 5. The range of that function is from minus 5 to minus 4. And the significant thing about that, if we come back here, the domain of the Cartesian equation f of x is the same as that. It's the same as the range of g of t. So therefore, the domain of f of x is that x has to be between minus 5 and minus 4. And that's what they asked us to find in the question. So we can now say that a must equal minus 5 and the upper limit b must equal minus 4. Okay, part 2 asks us to go further. So that's what we've done so far. We had a parametric equation. We wrote it in Cartesian form to get that. And we've just worked out the domain of that function, which it has to be from minus 5 up to minus 4. We're now asked to find the range of this function. Okay, again, going back to the last lesson, we've got parametric equations, x equals g of t and y equals h of t. The range of the Cartesian equation, f of x, is the same as the range of h of t. What's h of t? That's the parametric equation in y. So that's y equals cos 2t. So this time we're going to have to look at y equals cos 2t, again, using the same domain they gave us in the question, from minus pi by 2 radians up to plus pi by 2 radians. So I'm going to sketch cos 2t in that, for that domain. And that is what cos 2t looks like. It's the same as cos t, but squeezed in by a scalar factor of 2. So cos 2t from minus pi by 2 up to plus pi by 2 will be the red part of the curve there. And again, what we need to find for that is the range of this function. So what's the highest it gets to? What's the lowest it gets to? Well, the highest it gets to is plus 1 up here, and the lowest it gets to is minus 1 at both of these 2 points. So that's what we've just done. We've said that the maximum value of cos t is 1 between minus pi by 2 and plus pi by 2, and the minimum value of cos t is minus 1. Therefore, the range of h of t, which is just y equals cos 2t, is between those two limits. So it's from minus 1 up to plus 1. And then finally, we can say, well, what we want to find, which is the range of the Cartesian equation, f of x, that'll be exactly the same thing. So that'll go from -1 up to +1. So what have we done? That's the end of the question, by the way, but we'll just quickly revisit exactly what we've done to make things clear. So in parametric form, we had two parametric equations. First of all, x equals cos t minus 5, which had a domain of t from -π/2 up to +π/2, and we worked out the range, and the range for that function was from -5 to -4. The other parametric equation was y equals cos 2t. In the question, we were told that that went from -π/2 to +π/2, and that the range of that function was from -1 up to +1. We then calculated the Cartesian form of that equation, which is that, and we worked out its domain and range. And just look quickly at where they come from. So the domain of the Cartesian form, -5 to -4, that's the range of the function we had for x. And the range of the Cartesian equation, -1 up to +1, that's the range of the parametric equation that we had for y. So this is the same as this is the same as this. Now, if I wanted to sketch this, then that's the whole of the quadratic, y equals 2x squared plus 20x plus 49. And if I was drawing the whole thing, then it would look something like that. But I'm not drawing the whole thing. The domain is restricted from -5 to -4. So that's -5 on the x-axis up to -4 on the x-axis. That will just give me that part of the curve. And just to remind you what domain and range mean. So the domain is -5 to -4 because that's the x values that the function can take. And the range is from -1 up to +1 because that's the y values that the function can take. Okay, one last example. Example 3, by using the identity cosec squared t equals 1 plus cot squared t, show that the parametric equation x equals 5 cot t, y equals cosec t, between 0 and pi can be written in Cartesian form as y squared equals 1 plus x over 5 all squared. Now, you don't have to worry about domains and ranges at all in this question. It's just like question 1. I'll let you have a go at working your way through all of this yourself. And pause the video, come back to me when you're ready. Okay, let's have a look. So we're given y equals cosec t. That means y squared is equal cosec squared t. And I've found that because I know what I'm heading towards. I want y squared. X equals 5 cot t, we're given that in the question. That means x divided by 5 is equal to cot t. That means x divided by 5 all squared is cot squared t. And that means 1 plus x over 5 squared is 1 plus cot squared t. And I found that because I knew that it was what I needed to find. We were told in the question that that's what we were heading towards. And now we can just use the identity. Cosec squared t equals 1 plus cot squared t. So substituting in for cosec squared t is y squared, and 1 plus cot squared t is equal to this. We get straight to the answer. Y squared equals 1 plus x over 5 all squared is the Cartesian equation of the curve. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 23 and have a go at exercise 3b. Thank you very much for listening, and cheerio.